day 80 of doing a LeetCode problem every day until I get a job. All right, guys, you know how we do. We're back again, another day, another LeetCode problem. Hope you guys have been keeping up. Hope you guys got well rested yesterday because we have some learning to do today. But before we get started, guys, don't forget, bring your mouse right over here. Click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need you guys to drop that bank emoji in the comment section so we can run this engagement up and we can build this Swift community together and help bring more awareness to the Swift community and get more people interested in Swift so we could grow the Swift community as a whole, guys. Now, with that being said, I know why you're here. You want to see what's up with the question. And today we have question number 72, edit distance. The difficulty level is medium, guys, but don't worry. We're going to keep the solution as simple and easy to understand as possible because we're all trying to learn here. And there's no point in writing code that nobody is going to be able to understand or practice or internalize later. So, now, with that being said, let's get to the question. And today the question says, given two strings, word 1 and word 2, return the minimum number of operations required to convert word 1 to word 2. You have the following three operations permitted on a word. You can insert a character, you can delete a character, and you can replace a character. So, let's look at the example so we can see what it is that they want us to do. So we have input word 1, which is a string, which is horse, and then we have word 2, which is another string, which is ROS. The output is 3. What they want us to do is convert this word into this word using these three operations, and let's look at the explanation so we can see how they did it. So first we had horse. The first thing they did was they replaced the H with the R, so now it was Roars. Excuse me. But we're not finished yet. Then we have to remove the second R, so now we just have rows. Then we have to remove the E, and now we have ROS, which is this. And then that is how we successfully converted horse into ROS. We just replaced the H with the R right here, and then after that we just removed the second R and removed the E, and this is what we were left with at the end. So let's look at example 2. It's a little bigger word. It's a little more operations we have to do. So let's look at it just in case we missed something the first time. So this time we have the input. Word 1 equals intention. Word 2 equals execution. The output is 5 because that means we had to do 5 operations in order to convert this word into this word. And here are these explanation shows us the operations we had to do. So the first thing we had to do was remove the T, the first T right here. First thing we do, we remove this T. Then the second thing we had to do is we had to replace the I with the E. So this I we had to replace with this E, right? Then after that we had to replace the N with an X. So we had to turn this N into this X. Then we had to replace the N with the C, so we had to turn this N into this C right here. And then at the end, we just had to insert this U right here. So now we have the word execution, or yes, execution, sorry. Oh, and yeah, here's the example of how it would look after each operation. So first we started with intention. And I mean intention because we removed that T. Then we had intention because we replaced the I with an E, right? Then we had extension because we replaced the N with the X, and so on and so on. So let's see how we're gonna code this, guys. It's a little bit of a lengthy code, but it's not too bad. We'll get through it. And the first thing we're going to do is we are going to declare constant call M, and we're going to set that equal to word1 dot count. Then we're going to do the same thing, declare another constant call N, and we'll set that equal to word2 dot count, right? Then after we do that, we're going to say if M is equal to 0, then what we're going to do is we're going to return, that's return N, right? So if word 1 is nothing's in word 1, then we have to replace all the letters. And then we're going to do the same thing for n. We're going to say if n is equal to 0, then what we have to do is return m. Excuse me, guys. Return n. So if n is equal to 0, then then we have to delete all the characters in m. So if m equals 0, then we have to replace all the letters. If n equals 0, then we have to delete, what in the world was that? Then we have to delete all the letters. That's basically what that operation is doing, or those if statements. Then we're going to come down here, we're going to say let word1 equal an array of word1, so we could work with it. Then we're going to do the same thing for word2. We're going to say let word2 equal an array word2. Then we're going to come down here and we're going to say declare a variable. We're going to call this DP for dynamic programming. We're going to do an array with the repeating account. So the first thing we're going to do array repeating. Then that is going to be a 2D array, so that it's going to be repeating another array that's going to be repeating 0. And then the count for the inside array is going to be n plus 1. Then we're going to come outside those parentheses, but still inside the other parentheses, and we're going to say count, and that count is going to be m plus 1. Then we're going to come down here and we're going to say for I n 1 through m. Then what we are going to do is we're going to say dp I 0 equals I. Then we're going to do the same thing and we're going to say for I n 1 through n, that should be 3 periods, n. Then what we're going to do is dp, first it's going to be a 0 this time. Then we're going to open up the array brackets again and it's going to be a j. Then we're going to say equals j. Then we're going to come underneath that for loop and we're going to say for I n 1 through m. Then we're going to say for j n 1 through n. What we're going to do is we're going to say if word1, then we're going to open up the array brackets. We're going to say I minus 1. Then we're going to come over here and say equals word2. Then we're going to say open up the array brackets and say j minus 1. Then we are going to come over here and we are going to say dp I, come over here and say j. Then we're going to come over here and say equals dp, open up the array brackets, I minus 1, come outside those array brackets, open up some more array brackets and say j minus 1. Then we'll come down here and we'll say else. Then we will say over here dp, open up the array brackets I, then do the same thing, open up the array brackets j. We're going to say equals, then we're going to find the minimum. And we're going to open up the parentheses. We're going to say dp, open up the array brackets I minus 1. Then we're going to come outside of those array brackets and say j, or open up some new array brackets and say j. Then we're going to say comma. Then we're going to say dp. Then we're going to open up the array brackets, say I, come outside those array brackets, open up some more brackets, say j minus 1. Then we're going to come outside of those brackets one more time. We'll say comma. We're going to say dp, open up array brackets I minus 1. Then we're going to come outside of that and we're going to open up some more array brackets, say j minus 1. Then we're going to come outside all of that and we're going to say plus 1. Then we are just going to come down here and we are going to return dp. Then we're going to say m, open up the array brackets again, n, guys. And that should be all she wrote. Let's run it and see how it runs. Hopefully it runs correctly how it's supposed to. Ooh, there it is. You know, it's always a little little pesky thing. Let me see, what is that? Nope, it wasn't a space. What is that? Cannot find J in scope. Oh, excuse me. This should be for J and 1 up the end, not I. So let's run it again and see what happens. Let's see. See, it's always something. You never could be. Oh, I already see it already. This should be an array bracket. I messed that up last time. That's my bad, guys. So let's run it again. See what happens. You can never be too sure. You know, that's why you run it first before you submit it. So it ran fine. Let's submit it and see if it still works, guys. Fingers crossed. Fingers crossed. Let's see how it does. And it's accepted. 12 milliseconds beats 50% of users with Swift. You know, it could be better, but I feel like this is a good solution that is easy to understand. So when we studying this on our own time, we can study this and we can live it, learn it, love it, guys. But get one more look at it, one more look at it, one more look at it. Get that good code, get some of the good code, get a look at that good code. And I'll see you guys tomorrow for another day, another LeetCode problem. Peace.